Hello everyone. Today we will talk about a very important question, or you can say very important topic from inorganic chemistry, and that is F block element. In this session, we'll talk about what are F block element and why they are known as inner transition series elements. Including this, we'll study about some of the very important properties of a block element. Now let's start with the topic basic introduction of a block element. The elements for which the last electron enters into f orbital are known as f block element. अगर आप किसी एलिमेंट का इलेक्ट्रॉनिक कन्फिग्रेशन लिखते हो और लास्ट इलेक्ट्रॉन f ऑर्बिटल में एंटर करता है, then such type of elements are known as f block elements. F-block elements are also known as inner transition series element or inner transition element. Now the question is that why the F-block elements are known as inner transition element. The answer is very simple, that like transition element, F-block elements also having tendency to show more than one oxidation state, which means they have tendency to show the variable oxidation state. And during the removal of electron from n minus to f orbital, these are also known as inner transition F block element or inner transition element. Now, the F block elements are further classified into two parts, and which are 4F block elements and 5F block elements. The elements for which the last electron enters into 4F orbital are known as 4F block element, and these are also known as elements of first inner transition series, which consists of 14 elements, and these are known as lanthanides because the starting element of this series is lanthanum. And it is quite interesting to know that lanthanum belongs to D block element, but since the entire series starting just after the atomic number of lanthanum, these are supposed to be lanthanides or 4F block element. This series particularly contains 14 elements, and these are also known as rare earth element. Now similarly, the 5A block element, the elements for which the last electron enters into 5f orbital are known as 5f block element or second inner transition series element. These are also known as actinides because the starting element is actinium, and the series starting just after the atomic number of actinium. Now, most of the elements of actinoid series are radioactive in nature, and the elements after the uranium are known as transuranic element. Now let's start with some very important key point by which you can write the electronic configuration of any of the 4A block element or 5A block element. First of all, you must remember the general valence shell electronic configuration of F block element or inner transition series element, and that is n minus 2 f to the power 1 to 14 electron, then n minus 1 d, 0 to 1 electron, and ns2, where n represents the principal quantum number and it gives the idea about the period of the specific A block element. Now, for the 4A block element, the series contains 14 elements starting lanthanum to deuterium, and the general electronic configuration for lanthanides Xc 4F1 to 14. Xc represent inert fault and that is the number of core electron. 4F1 to 14, 5d0 to 1 and 6s2, which means the value of n is 6 and lanthanide belongs to 6th period in the periodic table. In case of 5A block element, which are known as actinide or actinide series, also known as second inner transition series, starting with the element having atomic number 90 to 103, that is thorium to lawrencium, and its electronic configuration, general electronic configuration, Rn 5F1 to 14, 6d0 to 1, and then 7s2. So this is the basic introduction about a block element, and now we'll study about the electronic configuration, how to write down the electronic configuration, and how by using electronic configuration we can determine the oxidation state of a block element. Just first of all note it down all this thing. Now, after completing the basic introduction about a block element, we are in the section properties of a block element. And first one is very important, and that is writing down the electronic configuration. General electronic configuration for 4A block element, which are known as lanthanide, is 4F 1 to 14, 5D 0 to 1 and 6S2. The value of n is equal to 6, which means lanthanides belongs to 6th period in the periodic table. And if you want to write the complete electronic configuration in general form, what you have to do, you just put xenon and write down 4F1 to 14, 5D 0 to 1 and 6S2. Now here we can see that we have already mentioned the electronic configuration of lanthanoids starting from lanthanum, that is 57. The electronic configuration is, valence cell electronic configuration is 4F0, 5D1, 6S2. Then the next one 4F2, 5D0, 6S2. Similarly 4F3, 5D0, 6S2. So all the electronic configuration for each of the elements present in lanthanide series we have already mentioned, and with their oxidation state, the starting element of 4A block element is lanthanum and its oxidation state is +3. Similarly, some of the lanthanides having tendency to show oxidation state of +3 and +4. In some cases, the oxidation state is +2, +3 and +4, which indicates that The common oxidation state for lanthanoid is plus 3, but sometime it can show plus 2, plus 3 and plus 4 oxidation state. And the stability of oxidation state is related with the f orbital electronic configuration, that is F0, F7 and F14, which indicates that if there is f orbital is completely empty or half filled or full filled for a given electronic configuration with respect to the oxidation state, then that oxidation state will be highly stable. And these are half filled, full filled and empty f orbital electronic configuration gives the idea about the stability of the oxidation state. So, if we want to see the stability of oxidation state by taking a particular example, that is EU, you can see that the general valence electronic configuration used to write the electronic configuration of EU or europium, that is 4f7 5d0 6s2. So in plus 2 oxidation state, if we write EU plus 2, which means electron will remove out from 6s orbital and it will have 4f7 electronic configuration for particularly for 4f orbital, which is half filled and which indicates that plus 2 oxidation state for europium consider as stable oxidation state because it gives the stability by half filled f orbital electronic configuration. Now, if we want to see the another oxidation state plus 3, you can write like this also. Plus 3 means there will be removal of 3 electrons from europium, 2 from 6s orbital and 1 from 4f orbital. So you will get the configuration 4f6, which simply indicates that plus 3 oxidation state is unstable oxidation state for EU and plus 2 oxidation state is highly stable. By using this method, you can check it out, the stability of different oxidation state, but you must remember one thing in your mind, that the stability of oxidation state is simply related to the half filled, full filled and empty f orbital configuration. In our next class, we will talk about some of the more important properties of f block element. Till then, thank you and goodbye.